Hello friends, so now we are going to dive deep into the world of microservices and monolith applications. We will understand that what monolith applications were and why they came into the existence. Then we will realize what were the issues associated with it and how microservices was much better approach, what microservice applications are, how to develop them, what are different strategies to implement them, what are domain driven development, what is event driven development, what are the different testing strategies, and all the characteristics, advantages and disadvantages related to microservice architecture. So without any delay, let's get started. Okay. First, let's try to simplify what microservices is. Microservices is nothing but the ability to distribute the tasks that are going to be separate from each other so that we can independently grow them on their own. And if we need, we can make changes to them without impacting overall the entire ecosystem as a whole. Now I know what I just mentioned might go above your head, but don't worry about it. Let's try to understand this with a real life example. Imagine that currently you are the owner of this particular restaurant. And now because this is a very new restaurant, you don't have means to ask for additional help or hire more people to do different kinds of stuff. Now in this scenario, you have to be responsible for a bunch of different things. Now in this case, since you are the only person responsible for doing all of these things, there are a lot of things that could go wrong. Imagine for a scenario that maybe suddenly this is a busy night at the restaurant and immediately 50 people just rush into your restaurant all at once. Do you think you would be able to justifiably help them out or do all of their needs? Are you going to be able to cook food for all of them, or take orders for all of them, or take payments for all of them, or help them out? Maybe they might have some special needs. Can you accommodate them? No, right? Because it's only you are working and you are not scalable enough to complete all of these tasks for all 50 people. Maybe there are like 5 or 10 people, you are still able to manage that, you can juggle around and you can do stuff, but still this is not a sustainable model. Now the example we just saw, in this case you are actually behaving like a monolith application, because in a single application you are being responsible for all sorts of like 50 different tasks, and many tasks don't have to do anything with each other, but still everything is being taken care by the single piece of application. That is a wrong approach. This is what used to happen previously, like maybe 1 or 2 decades back, when companies started developing the application, and there were many logical reasons for that. Number one reason was that networking was not so great and we were still in the early days of the internet. On top of it, most of the companies, they were still adopting it, or they were still new towards this IT infrastructure and they didn't know how to proceed. So what they started doing is that let's say that you are company X. Now this company X might have a product, and this product might be something like, let's assume Netflix. Okay. So in the early days of Netflix also used to be a monolith application, where initially Netflix started as sending out movies to anyone all across world. For that, they created a website, and in their website they had they would ask you to enter your address and the movie name and pay the money, and once you have these things, they would ship out the movie to your physical home address. Now in this case, they were only dealing with 3 main functionalities. First one is finding the movie, second one is collecting the payment, and third one is shipping out the movie or building the inventory management system. So from their perspective, it makes sense to create just one large application that is going to contain all of these features. Then eventually, over the next few years, Netflix kept adding more and more functionalities into their system. They kept adding things like more movies, international cinema. They started reaching out to people not only in North America, but North America, Canada, Europe, and other countries. Plus they started doing advertisement. Plus they started streaming the movies on their existing website. So now it became larger and larger and larger, at a point where it is impossible to manage all of the functionalities, all of these features. On top of it, keep on adding the new features and make sure that everything runs in scalable and smooth manner. Why? Because many times you might need that one service might needs more resources, meanwhile other services can stay behind the scenes. For an example, if Netflix decided that, hey, instead of working in North America, we might start working in Asia and Europe and all the other countries as well. In this scenario, maybe the number of users increase significantly. On top of it, their geographical considerations increase significantly, but their Netflix office locations still remain relatively small, and their employees might also remain relatively small. Imagine that only one application, if that is responsible for doing all of these things, and then if you have to scale that application, you will have to scale the parts that are no longer needed to be scaled up, just in order to make sure that other part scales up. So these were some of the inherent issues with the monolith applications. Next issue with the monolith application is that currently for this scenario, they also have to make sure that how do we ensure security for entire purpose. Plus, because there could be some SQL injection query leakages. Plus, there could be potential that maybe if you're one of your services that needs to be public facing, is also going to allow all the internal services to be public facing at as well at some point, because everything is just jumbled up together. So that exposes additional security risk. So there were many certain issues with monolith applications, things like scalability issues, resource allocation, security concerns, and also it was not a sustainable model. Just like you alone running an entire restaurant that is going to expect to have maybe 50 or 500 customers is not a sustainable model. Same way, monolith applications are not a sustainable feature for the IT industry. In that scenario, they started breaking out the logically separate pieces, and they also decided that if, let's assume that currently we have a payments mechanism. So now this payments mechanism can be a completely separate entity on its own, and whenever any consumer needs to make a payment, they can just straight up call this application, call this piece of code, and then complete all the things that this payment application needs to do. Maybe stuff like how much money they are going to collect, what is going to be your user ID, and collect all of these information, take the money. Once the money has been done, store that record somewhere in a database, and once we have that information, give back the confirmation to the application that came in that, hey, the payment for this particular person X, Y, Z or Z has been received. So now they can move ahead and they can start doing, or they can start watching Netflix on the stream. Imagine that how easy it started making things, just because they started implementing the microservices architecture. So over the next few years, what Netflix did is, first of all, they started breaking their application. They created a separate front end, then they created a separate back end, then they created a separate data store, then even in the front end, they started creating bunch of different components in their application. So one component might be responsible just for showing the thumbnails of the movie. One component was responsible for showing the description of the movie. One component was responsible for showing the user profiles of their existing Netflix system. So this is how they started breaking the front end pieces. In the back end pieces, they started creating bunch of different combination of separate entities or separate applications that can live on their own, grow on their own, and destroy on their own. And if they are not working, still the Netflix would be able to bypass them and still started giving the continuous stream of information to the user. So things like maybe a payment can be one of the things. Second backend mechanism can be streaming movies. Third can be security amongst data center. Next can be processing the movies. So all of these things they started doing separately from one after each other, and whichever piece needed. So let's assume that a new consumer comes in, says to the front end that, hey, I want to buy a Netflix subscription. The subscription only needs to call the payment mechanism and say that, hey, this person needs to pay for the subscription. Make sure that you are giving the payment systems and all the things needed. Once that payment has been completed, now this person would have access to all the entire remaining front end, and they can start watching movies and they can start doing all sorts of things. But in this flow, this processing of movies does not needs to be impacted, because this current user is trying to pay something for the Netflix. So you are separating the resources. Plus, we suddenly imagine that Netflix just started operating in a new country, maybe like Australia, and they started receiving 100 million users in a single hour. Huge numbers, but just say one example. Still, in this case, we can just start growing the payment mechanism exponentially with like maybe 50 resources or 50 instances without hampering all the other existing services. So scalability can happen on their own. All the services can grow on their own and without causing any delays between any two entities. So these are massive benefits compared to the monolith application, because in the monolith application, if you had to grow, you have to grow the whole thing, not just one component of the application. So that's why more and more microservices started coming into the existence. Now we know conceptually what microservices are. Now let's try to imagine that how they are going to communicate with each other. So I just explained that currently we might have this microservices that is currently responsible for user profile. Now all the things this microservices provides is that, hey, if you provide me the user ID and the proper authenticated credentials that you are able to see that user ID, then I would be able to go dig into my database, and I will provide you all the information that are needed for that particular user profile. Maybe things like their movie preferences, their location, their email address, their phone number and whatnot. So now this can live on its own, and all the things that it is going to do is maybe communicate with REST or SOAP or some set of APIs. Typically for microservices, REST still remains one of the most popular mechanism for communicating between any two microservices, but there are other ways as well. So same way, we are going to have bunch of these clusters who are all going to say that, hey, this is my REST or this is my API contract, and if you provide me these information, you can expect to get these answers. Plus they might be connected to separate databases in the backend, or many times it could be possible that some databases are referencing with each other. So in this case, we can say that two microservices are sharing the same database. So that makes things more complicated, but still not as complicated as having a monolith application running the whole show. In that case, so now we know some idea about how microservices operate. Now let's try to understand that what are some of the issues with existing microservice architecture as well, and what are the current potential considerations we will have to make. Number one thing is that security still remains concern, because now previously in the monolith era, you were only making calls to some applications, and then all the applications were communicating internally and they were able to do a lot of things. In this scenario, you might have 50 different microservices running parallelly with each other, and you have to make sure that how you can segregate them, how you can make sure that they are all being properly secured and they are all communicating properly. So that is number one concern. Number second concern is that cross-reference database queries. In this scenario, if you have just bunch of different microservices call same sort of database and keep on doing a lot of read and write functions, this becomes a cause of concern, because many times one microservice might expect to change the data and the data might not have been updated to all the replicated copies, and same data, if that is being asked by some other microservice, then data consistency can become a challenge. So you will need to consider that. Next thing is that you need to make sure that you are following the principles of domain driven architecture, that all the microservices you are creating, they are logically from the business point of view and also from the technology point of view are separate from each other. You don't want to have two applications doing the same stuff or being tightly coupled, still having their own separate microservices. If things are tightly coupled, it's better to keep all of those functionalities together. You only want to have loosely coupled microservices that are separate from each other, building and creating or conveying the scenarios. So in my personal opinion, microservices are a great approach. You can deploy and run these microservices explicitly from each other. You can grow them explicitly from each other. They're much better in terms of scalability and reliability. It helps you achieve all sorts of like 4 nines and 5 nines availabilities. But the only problem is if you are not considering all the principles, things can get out of hand pretty quickly. So make sure that you are doing all of this. I know that in this video, I just explained you a very small scale watered down version of what Netflix system looks like. Eventually in the future, we are going to build a completely new video on how the entire Netflix ecosystem works, what are the different moving parts, and then we will do a video like maybe design a Netflix system. Okay, so that's gonna happen in the future. But meanwhile, I hope you like this video. Let me know in the comments if you think I could have done something better or something else. And till then, take care.